I'm going to give you a few more examples of doing vector addition and also of doing vector subtraction. Subtraction functions just like addition. It just depends on what you're trying to do with the problem. A subtraction problem is a vector addition problem where instead of being given the two things you're adding, you're given one of them and then the answer, and you wind up subtracting to find the other. Let's take another example of a vector addition problem. Let's say a river is flowing at 2.4 kilometers per hour at south by 31 degrees west. A swimmer sets out at 1.1 kilometers per hour at say north by 25 degrees west. And we have to clarify that this is relative to the water. How fast and in what direction is he going relative to the land or the shore or whatever you want to call it. All right. So this is the river's moving, and then the swimmer's swimming in the water, moving relative to the water. The water's also moving, so it's carrying him downstream. This is another case where you just add vectors. The velocity of the river plus the velocity of the swimmer relative to the river gets you the velocity of the swimmer relative to the ground or the land or whatever you want to call it. So that's how that works. We'll talk more about that a little bit later on, but for now, just know that it's a vector addition problem. So again, we need to turn our magnitude and direction into components, both of them, add the components together, and then change the result back into magnitude and direction. I would recommend right now pausing your video, working out the problem, seeing if you working through the problem yourself, and then checking your answer against what I do or what I get. So 2.4 kilometers per hour south by 31 degrees west. That's going to be 2.4 sine 31 negative 2.4 cosine 31, also negative because it's south and west, and sine is in the x component because south is first, cosine's with the y component for the same reason. North by 25 degrees west, so even though north is positive and it's first, west is still the x component of the vector. The x component is negative. 1.1, since north is first, we have sine in our x component, and 1.1 then cosine 25 in our y component. We add those together, so negative 2.4 sine 31 minus 1.1 sine 25. That gets me negative 1.7. Store that as x. We got negative 2.4 cosine 31 plus 1.1 cosine 25. It's negative 1.06. Store as y. Square root of x squared plus y squared. That gets me the magnitude, 2 sig figs. It's 2.0 kilometers per hour. Inverse tangent y over x. That's me 31.9, 2 sig figs, that's 32 degrees. And this is a negative x component, so that's west. Negative y component, so that is south. So the swimmer is moving at 2.0 kilometers per hour at west by 32, degrees south relative to the land. Now let's take an example of a vector addition. Let's say a dog runs 8.5 meters at west by 32 degrees north. His owner is 12 meters at north by 11 degrees east from his original position. How far and in what direction must the dog run to get to his owner? And stop for a minute and think about this. Maybe draw it out. See if you can solve the problem. And then check on my solution. Now, you may have noticed this is a little bit different from other problems that we've done. So the dog has run 8.5 meters at west by 32 degrees north. All right. But his owner is 12 meters at north by 11 degrees east from his original position. So this is the 12 meters, this is the 11 degrees. And then the question is how far must it, and in what direction must the dog now run to get to his owner? So this is the vector that you're being asked for. Now graphically, this vector plus this vector gets you this vector. So this 12 meters at 11 degrees north is the resultant vector. So we're saying, if I call this vector 1, call this vector 2, call this vector 3, vector 1 plus vector 3 gets us vector 2. And we're trying to find vector 3. So, if we do some basic algebra, we can see that vector 3 equals vector 2 minus vector 1. So that's the operation we're going to have to do to find the answer to this question. Vector subtraction is exactly the same as vector addition. In the same way, that 4 minus 3 is the same thing as 4 plus negative 3. When we add vectors or subtract vectors, if we take vector u minus vector v, it's the same thing as vector u plus negative vector v. So we'll just attach negatives to each of the components of our second vector and then add them together. So vector 2 is how far away the owner was. So we've got 11 degrees, both positive components because we're in quadrant 1. Got 12. The x component goes with sine. So we've got 12 sine 11 degrees, 12 cosine 11 degrees. And then we're subtracting vector 1, it's 8.5 meters. 32 degrees is from the x-axis, so cosine 32 goes with the x component. Because it is heading west, the x component is negative. There's north, so the y component is positive, 8.5. And then sine is opposite over hypotenuse, so that's 8.5 sine 32. And then we just do the operation. We've got 12 sine 11 minus negative 8.5 cosine 32, so that's plus 8.5 cosine 32. That's our x component, 9.498, whatever. I store that as x. 12 cosine 11. Remember, the negative distributes to both components of the vector. So we have to subtract 8.5 sine 32. There's my y component, 7.498 2, 7. Store that as y. And then my magnitude, square root of x squared plus y squared, as always, comes out to 11.96. These are 2 sig figs, that's 12 meters at our angle, inverse tangent, y over x, 37 degrees. We look at our components, positive x component, positive y component, so that's east by 37 degrees north. So vector subtraction works the same way as vector addition, just kind of in reverse. You just attach a negative to the components of one of your vectors. But you do need to be able to understand, reading through the problem, you can't just blindly add together whatever vectors you see. You have to think about what's going on. You can draw it out if it helps you, or if you can just figure it out, realize, do I need to add these two vectors? Do I need to subtract them? What's going on here? So and again, the process is the same. You take your magnitude and direction, change it into component form, magnitude and direction in a component form, add or subtract, get the components of your answer, and turn those components into then magnitude and direction of your answer.